Hello students, secondary to chemistry. Now we are going to continue in lesson 2, modern periodic table. We have studied the two trends in the periodic table. The atomic radius, number 1, and number 2 is the ionization energy. We are now going to study the third and the fourth property of the elements in the periodic table, the electron affinity and electronegativity. We start now with electron affinity. When you want to remove an electron from the atom, you must add and exert energy to remove any electron from the atom. This amount of energy needed to remove the electron is called the ionization energy that we have studied in number 2, trend number 2. But now is the opposite. If you want to add an electron to a neutral atom, of course you will not exert energy, but you will get energy. This means that energy is lost or released when you add an electron to an atom. If the atom needs this electron and attracts this electron, the amount of energy will be higher. If the atom doesn't attract strongly this electron, the energy released will be small. The energy released when an electron is added to a neutral atom, the energy released is called electron affinity. So the definition of electron affinity is the amount of energy released when an extra electron is added to a neutral atom. And to be exact, this atom must be in a gaseous state. This equation represents that this is a neutral element, electron is added, extra electron. This electron comes out from the atom. This electron is not belonging to this atom. It's an extra electron from an outside source. Okay, this is a neutral atom and this electron is added to this atom. Now the atom is not neutral, it's a negative atom or ion. Okay, negative ion. And this energy is the electron affinity. Okay, delta H here is the energy lost. What is energy lost? This atom loses energy, so the energy is lost. But there was in the electron and the ionization energy, the atom gains electron. Delta H was positive, but here delta H is negative because the atom loses energy. This is the energy on the right hand side, is the lost energy. The atom gains electron. What happens to the atom? It changes into a negative ion and energy is released. This energy released is called electron affinity. And because the atom lost energy, so delta H is negative. So if you want to compare between ionization energy and electron affinity, the amount of energy required must be exerted, must be exerted to remove the most loosely bound electron completely from an isolated gaseous atom. This is an neutral element and energy is added from outer source, so the atom gains this energy, so delta H here heat or energy is positive, and the atom converted into ion, positive ion, because it's lost an electron from inside the atom. This electron is coming from the inside of the atom, but here this electron is not from the inside of the atom, it's from an external source of electrons, okay, from another atom, but not from the X atom. X atom is neutral, equal positive and negative. Positive protons and negative electrons are equal in number. Here this is a neutral atom, and an electron is added, so the atom changes into a negative ion, because it has greater number of electrons than protons. So and energy is released out from the atom. The atom lost energy, so the delta H is negative here. This is the definition of the electron affinity. This equation, of course, represents the electron affinity, not the ionization energy. In the ionization energy on the left hand side, but here energy on the right hand side is the electron affinity. So this is the answer. Electron affinity, these are some questions, comparison, and so on. Now to the new concept called electronegativity. Suppose that two atoms are bonded together. Here the atom is in gaseous state. It's a free atom. It's not a bonded atom. Here in the electron affinity, when an electron to a neutral atom, free atom, not bonded with other atoms, okay? But here in the electronegativity, two atoms are linked together, bonded together, okay? This electron is called bond electron, the electron common between the two atoms, okay? This is a covalent bond, for example, and this electron belonging to both the two atoms. Will this electron be attracted more to the left atom or to the right atom? It depends on the strength of attraction between the nucleus of each atom to the electron. If the attraction between this nucleus and the electron is greater than the attraction between the same electron and the other nucleus, this means that the electron will be close to this one because attraction is greater, and far away from this because its attraction between them is lower or is weaker. Strong if this attraction is greater than this attraction, we say that this atom has high electronegativity. The atom which attracts electron more strongly than the other has higher electronegativity. The atom which has low electronegativity attracts electrons loosely or weakly, okay? So electronegativity is a measure for the ability of the atom to attract electrons of the bond, not free atoms. Electrons of the bond are attracted between two atoms. The atom which attracts electrons strongly has higher electronegativity, and the atom which attracts electron weakly has low electronegativity. And here in this example, if the X atom has low electronegativity and the atom has the atom Y has high electronegativity, the electron will be attracted more to the one with high electronegativity. So this atom will acquire partially negative charge, and this one acquires partially positive charge. Why not positive and not negative? Why we put this symbol delta? This letter is called delta. Delta means partially negative and partially positive. And didn't you put negative or positive? This will happen if this atom attracts electron more and more very strongly. This electron will be transferred completely to this atom, and this electron will be lost completely from this atom. And in this case, we say that the bond is not covalent but ionic bond. If the difference is higher, is very higher in attraction, the difference is very high in attraction between the two atoms, the bond will not be covalent but will be ionic bond, because one of them will attract electron very strongly, such that it takes this electron completely and form fully negative charge, and the other will be fully positive charge without putting this letter. Okay, here is the opposite situation. Suppose that this atom on the right has the low electronegativity, on the opposite of here, the situation here, and this one has high electronegativity. High electronegativity means this electron will be attracted here more, so it acquires partially negative charge, and this one attracts electron has low electronegativity, means attraction is low, so the electron will be closer to that one with high electronegativity, will be closer here, so it makes this partially negative, and this will be the opposite, partially positive, because electron has got away from it. Okay, but will be closer here to the one with high electronegativity, so it acquires partially negative and partially positive. So partially negative or partially positive, it depends on which one has a high electronegativity. The atom which has high electronegativity acquires partially negative because it attracts electron more strongly. Okay, if the difference between the interaction of electron between the two atoms is very strongly, this atom will take this electron completely and forms negative, completely negative, not partially as it is here, but negative, and this will be positive. Okay, so you must understand the difference between electron affinity and electronegativity, the amount of energy released. This amount of energy released when an extra electron is added to the neutral gaseous atom, and this is expressed in energy, because it is the energy, the amount of energy, means that the unit here is joule or kilojoule, refers to the atom in its single state. Okay, atom alone. Here the tendency, it's not the energy, the tendency, the ability of the electron, tendency, or you can say the ability of an atom to attract the electrons or the electron, one or more, of the chemical bond. The atom here is not free, it's bonded, two atoms together. It's a competition between the two atoms, but here no competition, one only atom. It's not an energy term, just a value which expresses, but it has no unit here. Electronegativity is number also, but it has no unit. But here energy, the term, it has a unit, joule, kilojoule, and so on. Refers to the combined atom, but here to the single atom. These are numbers that expresses the extent of attraction of the atom to electron, or we can say that these numbers represents the ability of the atom to attract electrons. Okay, the hydrogen atom electronegativity of the hydrogen atom is 2.1, for lithium 1, for beryllium 1.6, and so on. These are not for keeping in mind, but just for knowledge. Okay, you can keep in your mind some important elements such as the electronegativity of hydrogen, electronegativity of magnesium, sodium, of carbon, of nitrogen, hydrogen, fluorine. 6 or 7 important elements are only needed to be kept in your mind to answer many questions. Okay. Importance of electronegativity. The importance of electronegativity is very applied here. The difference in electronegativity between the bonded atoms will determine the type of bond. If the difference between electronegativities of the two bonded atoms is higher, for example, if the difference between the two bonded atoms is greater than 1.7, the bond between the two atoms will be ionic bond. So one of the two atoms will attract electron very, very strongly than the other. So the bond will be ionic. For example, the difference between the electronegativity between sodium and the chlorine is from the above table, is greater than 1.7. So the bond here between sodium and chloride, sodium and the chlorine, is ionic bond. So Na plus and Cl minus, without partial. Okay. If the difference between the bonded atoms is intermediate between 1.7 and 0.4, sorry, this difference is relatively intermediate. So we say that this bond is polar covalent bond. And here is H partial positive and Br partial negative. If the difference in electronegativity is between 0.4 and greater than 0, okay, if this difference is less than 0.4 and greater than 0, we say that this bond is non-polar bond. If the difference is completely 0, for example between carbon and carbon, we say that this bond is pure covalent. Carbon 2.5 and 2.5, the difference between them is 0. Oxygen molecule O2, H2, and chlorine Cl2 also, the same number, means 0. I'll say that the bond between oxygen and oxygen is pure covalent bond. Between hydrogen and hydrogen, or in H2 molecule, the bond is pure covalent bond, and so on. Thank you for listening.